What is Solow Growth Model? The Solow Growth Model was the economic model named after Robert Solow, the winner of Nobel Prize in Economics. The Solow Growth Model analyzes change in the level of output over time as a result of change in the saving rate, the population growth rate, and lastly the rate of technological progress. In other words, this model helps us to understand the factors that determine the economic growth for different countries in the world. A key part of this model is a production function. It describes how a raw material or inputs are used to produce goods and services or output. Let's rate these goods and services or output with the capital letter Y. For the factor of production, the first key input is the capital K or the capital. These capitals are things like machines, tools, computers, and so on. Next key input is the capital N. It is represented for the people or labor. Last but not least is A or the state of technology. We can think of capital, labor, and technology being used together to produce the output, and that's the idea of the production function. Right now, our production function is really complicated, so we are going to use a super basic model called the basic Solow growth model. To construct the basic Solow growth model, there are two things we need to understand. Let's dig into the first part, the investment. In the production function, assume that there are only capital and labor, so now our production function will look like this. Then assume that the production function is constant return to scale. This means when we double the input, the output will also double. So if we divide this production function by n, the aggregate production function will turn to be what we call per worker production function. In the graph, we will see that as capital per worker goes up, output per worker will also go up too, but the output will go up at a decreasing rate. This is what we call the diminishing returns. When people receive income, they can choose to spend their income for their consumption or save it for their future consumption or the investment. How much people will save will depend on the saving rate, which is the fraction of income that is saved, represented by the small letter s. And because the investment equals the saving, or I is equal to s. So when the income is multiplied by the saving rate, it is also equal to investment. Again, if we divide the investment by n, the equation will turn to be the investment per worker, and it will equal to the saving rate multiplied with the output per worker. Also, the investment per worker is also equal to the saving rate multiplied with the function of k. So when we draw the investment curve together with the production curve, the investment will be lower than the production because we save some part of income for the investment and spend the rest of income for consumption. Next, we are going to talk about the depreciation. Even though the increasing in capital can increase the total capital stock in the economy, there is a problem with these capitals too. For example, the farmer has the tractor in his farm to help his works. But as the years go by, it will end up breaking down. In short, we say there is a depreciation. Depreciation per worker equals to the capital per worker multiplied by the depreciation rate, or delta. From that information, we can model the relationship like this. As depreciation increases at a constant rate of delta, the more capital accumulation you have, the more depreciation you will have too. When the capital in the next period will equal to the undepreciation capital in this period plus the investment, or the capital per worker in the next period will equal to the undepreciation capital in this period plus the investment per worker. If we want to change in the capital stock, we will subtract the capital per worker in this period from the capital per worker in the next period. Then we find out that the change in the capital stock is equal to the investment per worker minus the depreciation per worker. In short, we call this equation the equation of motion K. When we put the investment per worker and the depreciation per worker together, it will turn out like this graph. When the investment is large enough to cover the capital depreciation, we can say that the investment per worker is equal to the depreciation per worker. At this point where these two lines intersect, we will reach what is called the steady state. The steady state is the key to understand the Solow growth model. At this level, there is zero economic growth because there's just enough new capital to offset depreciation. Also, when we reach the steady state level of capital, we've also reached to the steady state level of output. Now, suppose you end up on the other side of the steady state point, over here. You'd find that depreciation is greater than the investment. That means some of the capital stock needs repair, but there isn't enough investment to do all of the need repair. So, the capital stock gradually shrinks and pushing we back to the steady state. On the other hand, if we end up on the left of the steady state, we would find that the investment is greater than depreciation, so the capital stock is gradually growing, which we pushing us toward the steady state. As we see, either way, we always end up converge to the steady state. To sum up, when the capital is more or less than the steady state, in the end, the economy will adjust itself back toward to the steady state. And this is all about the introduction of the basic Solow growth model.